Hello friends, so today in this video we are going to solve one question which was asked in GATE 1994. So the question is, state whether true or false, given a reason for your answer. So the statement is, a p-type silicon sample has a higher conductivity compared to an n-type sample having the same dopant concentration. Okay, so before answering this question, we need to understand some basic of conductivity and how it is dependent to p-type and n-type material, right? How conductivity is different in n-type material and how it is different in p-type material, and which one is higher, either in p-type or in n-type. Then we would be able to justify that statement, whether this statement is true or false. Okay, so the relationship that we need to see between the conductivity and the concentration of n-type and p-type, which can be written as the conductivity is equal to Q, right, mobility and this carrier concentration, right? So here you can see that the Q is charge of electron, right? Mu is the mobility, right? It could be either this mu could be for p-type material it is mu p, and for n-type material it is mu n, right? And this n is the carrier concentration. For n-type material, the carrier concentration for the majority is written as n, right? And for the p-type it is p. So I'm in general writing is like this, and right, for you can also write q mu into p, right, in a simplified manner. I'm just writing it. So from this relationship you can see that the conductivity is directly proportional to mobility, right? So your conductivity is directly proportional to your mobility. So this is the important factor to know to answer this question. So as we know that, right, so if your conductivity, so if your mobility is higher, right, your conductivity would be higher. And one thing we know from the previous video I have also explained, we know that the mobility of electron is higher than the mobility of holes, right? In some book they say the electron mobility is almost 3 times higher than the hole mobility. So this is the relation number, say this is the important relationship of 2 and this is the number 1. So now you can see that the conductivity depends on mobility, right? So if the mobility is higher, conductivity would be higher, and from equation 2 you can see that the mobility of electron is higher, right? The mobility of electron is higher. So here we can see that the mobility of electron is higher than the mobility of hole, right? And mobility is directly proportional to the conductivity, and as the mobility of electron is higher, so we can say that the conductivity of electron, right, the conductivity of electron would be higher for n-type material, because the mobility is higher for the n-type material, right, as compared to p-type material, so the conductivity of p-type material would be less than the conductivity of n-type material. So now we'll go to the statement and we'll see what this statement is all about. So this statement says that a p-type silicon sample has a higher conductivity compared to n-type sample, right? So p-type sample, that means there is hole, right? So holes, that means the mobility is less than the electron, and electron is always in majority carrier in n-type material. So here the statement is what? The statement is false, right? Because this statement says that the p-type material where holes is maximum has higher conductivity than the n-type material where electron is present. But in reality the conductivity is maximum in or higher in n-type material, because in n-type material we have electron in abundance and the mobility of electron is higher than the mobility of hole. So as a result we can say that the mobility or the conductivity of n-type material is always higher than the conductivity of p-type material. So the answer for this question would be false, and the justification would be this, whatever we have so far discussed. Thank you so much.